5-digit numbers are formed using 1, 2, 3, 4, 5 without repetition. If the probability that the number is divisible by 4 is k, then the number of divisors in the integer part of root 2 plus 1 whole power 1 by k is. First, let us find out the total number of 5-digit numbers. Total number of 5-digit numbers using 1, 2, 3, 4, 5 is equal to 5 factorial. Then let us find the numerator. Number of numbers which are divisible by 4. Which are divisible by 4. So for divisibility by 4, the units place and the tens place and the units place taken as a chunk should be divisible by 4. So the tens and units place can be, what are the options? It can be a 12, or it can be a 24, or it can be a 32, or it can be a 52. So we have 5-digit numbers. So 10,000s place, thousands place, hundreds place, tens and units as a chunk. This has 4 choices, but every time we'll be using 2 digits here. We are left with 3 digits for the 10,000s place, and 2 for the thousands place, and 1 for the hundreds place. So the number of numbers of the required form is nothing but 24. So probability is called as k. So k is equal to 24 divided by 5 factorial. So 5 factorial is a 120. When I cancel with a 24, we get k is equal to 1 by 5. So the first part of the question is over. Now we need to find out the integer part of root 2 plus 1 whole power 1 by k. What is the integer part of this? So first let me call this as some series called as S. Let me call another series as lambda, which is going to be its conjugate, root 2 minus 1 the whole power 5. Let us write the expansion of S. S is going to be root 2 plus 1 whole power 5, which is 5c0 root 2 power 5 plus 5c1 root 2 power 4 plus 5c2 root 2 cube plus 5c3 root 2 square plus 5c4 into root 2 plus 5c5, which is equal to 1. This is nothing but root 2 plus 1 the whole power 4. Now let me call root 2 minus 1 the whole power 4. This is going to be a decimal value. The whole power 5 will also give us a decimal value. So this is a fractional part. Any number between 0 to 1 raised to power 5 will be a small fractional value. Let me call it as a f. So the same series with the negative signs in between. So minus 5c1 root 2 power 4 plus 5c2 root 2 cube minus 5c3 root 2 square plus 5c4 root 2 minus 5c5. So what we are going to do is we are going to subtract one series from the other series, S minus F. So when I subtract, this term will get cancelled, this term will get cancelled, this term will get cancelled. All these terms will get added up twice. So it is going to be 2 times the value of 5c1 is 5, root 2 power 4 is a 4, 2 times 5c3. 5c3 is same as 5c2, which is a 10, into root 2 square is a 2. 5c5 is a 1. 1 plus 1 is a 2. 2 is pulled out, so I get a 1. This is going to be 20 plus 20, 41 times 2, which is equal to 82. S has some integer part and some decimal part. F has only a decimal part. And S minus F is equal to 82 indicates integer part. The integer part of root 2 plus 1 the whole power 1 by k, which is nothing but root 2 plus 1 the whole power 5 is equal to 82. Now the question is number of factors. of this integer part. Let us prime factorize this. This is going to be 2 into 41, or we can even count the number of factors, 1 into 82. So factors are 1, 2, 41, 82. So number of factors of the integer part of root 2 plus 1 whole power 1 by k is equal to 4. So the answer to this numerical question is 4.